The last section that we're going to cover in Chapter 6 is graphs of polar equations. And really there's just going to be a question or two on this on the test. But it's kind of a fun section because you can graph different things, and there's different types of curves that have famous names that you may see sometime in a college. I know I saw this in a college geometry class. There is some stuff in the book about testing for symmetry, but that's not the main thing I'm going to do. What I would ask you is, if something was in polar form, what are the maximum values of a particular curve that the radius would be, and when? So if I just take, for example, the first example that they have on page 542 is that r equals 4 times the sine of 3 theta. Well, when you think about this, we should know that sine can ever have a maximum. The sine of an angle is always greater than -1 and less than or equal to 1. So the idea of a negative radius doesn't really mean anything. It just shows a direction that you're going on the polar chart. So the highest this part will ever be is 1 or -1, which means that the greatest value for the radius will be 4. It'll also equal -4, which is a big radius. It's the same absolute value. So the maximum value that I would get for r is going to be 4. Okay? And so where does that occur? Well, that's going to occur when the sine of 3 theta is equal to 90 degrees. Typically 90 degrees is when sine is at its highest at 90 degrees. It's also going to be at its lowest at -90 degrees, or 270 degrees. And because we have 3 theta is equal to those things, then I could say this is going to happen at 30 degrees and 90 degrees. And a lot of times, because we set our range of values for the angles to go from 0 to 2 pi or from 0 to 360, then that would be the first times that they occur, but they're going to keep happening again and again. And then in truth, what happens is this: if I set theta for this one to be between 0 and 360, or in radians from 0 to 2 pi, what you'd see is it actually would go through what's called a 3-petal rose, and it would do each petal on the rose twice. The graph would start out, and since the sine of 0 is 0, it would start in here, and as our angle got bigger, then we would keep going out further and further, and so we would have something that would start going like this, and then once it got to this 30 degrees, that's when sine has gotten of 90 is 1, it's going to start backtracking, but I'm still changing my angle up, so it starts coming back like this. And then you'd find that it would go down like this and come back, and it would look like something like that. And so that's what the 3-petal rose would look like. I would want you to find maxes and mins. Okay? If you have something that looked like r equals 2 plus 2 cosine theta, this is going to give you a different picture. It's going to give you what's called a cardioid. Now again, I would want you to be able to examine what are the maximum values that we have. And again, cosine can be anywhere from -1 to 1. And so when it's at its most, I'd have 2 times 1, or 2. So the max for r would be 4. What's the minimum value of r? Well, if this part was -1, I'd have 2 plus 2 times -1, which would be 0. So I'm always going to have a positive radius. And so when you're graphing something like this, immediately when I have 0 degrees, the cosine of 0 is equal to 2. So I'd be all the way out here at 4. But as I start going through my angles more, it's going to get smaller and smaller and smaller until I get to 90 degrees, in which case I'm going to be at my lowest value because the cosine of 90 is 0. So I would start going through, and as my angle's changing, I'm having these large values, and then when I equal 0, I would come through and do something like this, and it would end up looking kind of like that, like a cardioid, like a heart. That's why it's called a cardioid. So there's all kinds of different ones that you can do. There's limacons, which is going to be a cardioid, except it's going to have a little inner circle. You have other types of rose curves. There's a spiral of Archimedes that you'll see on page 546. There's a lemniscate, which is something that looks like that. And they're just kind of fun, but again, the keys that I want you to be able to figure out is what are the maxes, what are the minimum values that your radius would have, and that's by understanding what are the possible trig values that you could have.